This is the MGA large battery crusher. Today I'm going to show you some of the tests that we would use this for and talk a little bit about it. This crusher is made in-house along with a lot of our hydraulic equipment here at MGA. It has a 1.8 by 3 meter test bed, so we can accompany any range of battery pack that we might see, from modules all the way up to a full-size vehicle battery. It has 1.5 meters of cylinder stroke, and we can move from 0.1 millimeters per second all the way up to 25 millimeters per second for the displacement rate. We can reach a maximum of 600 kilonewtons of force. Some examples of testing that uses this crusher is the R100 mechanical integrity test, along with SAE J2464. On our crusher, we can easily customize the test pole depending on which test standard is being used. We have a variety of pre-made poles that can be bolted on and off. Right now we have a 75 millimeter diameter single pole on here. We also have a 3-pole, and we have a extended pole that goes across the whole crusher as well. We're able to custom make a lot of different fixtures as well. We have done angled crushes with batteries to simulate vehicle roll during the quasi-static situations, as well as just flat and elevated crushes to simulate the battery in its more natural environment. With crush testing, you're evaluating a couple different things on the battery. In some test standards, you're looking to verify the integrity of the enclosure itself and make sure it can withstand a reasonable impact that you would see in a real-world environment. In other cases, you're actually testing the battery cells themselves. These are higher force or higher deformation crushes, and you're looking at how these cells deform and what point you start to see self-heating and short-circuiting between the cells. These tests can be destructive, and which is why we run all of them in our MGA battery containment bunkers to ensure that everybody stays safe during the test. One key element for crush testing is the isolation measurement. These are performed pre and post test on the battery to get a baseline of the isolation value before the crush, and then make sure that nothing changed or nothing changed significantly afterwards. The isolation is an important metric to gauge that the battery is safe if somebody were to come in contact with it, and isolation values that are too low can pose a risk to individuals.